All right, today we're tackling a true classic, designing a car rental system. You've probably used one, right? Seems simple enough. Find a car, book it, and you're good to go. But how do you stop two people from booking that last convertible for the same sunny weekend? That's the real challenge, and it's why this is such a great interview question. We're going to break the whole thing down from the very first requirement to a system that can scale to millions of users. So picture this. You're in the interview and this question gets put on the table. On the surface, it looks pretty straightforward. You search, you book, you pay. But underneath that simple exterior, there's this really fascinating web of services, data models, and some serious scaling challenges. The reason interviewers absolutely love this question is because it's a perfect little microcosm of a real-world app. It forces you to think about the entire stack. What does a user actually need? How are the different back-end services going to talk to each other? How do we store the data so it doesn't get corrupted? And maybe most importantly, how do we make sure the whole thing doesn't just fall over on a busy holiday weekend? So where do we start? The single most important step in any system design interview is to stop. And first, understand the problem. You never, ever want to just jump in and start drawing boxes and arrows. The first thing you do is ask questions and really nail down the scope. Here's how we're going to build this, piece by piece. First, we'll put on our detective hats and gather all the requirements. Then we'll sketch out the high-level architectural blueprint. After that, we'll design the database that holds the whole system together. And then we'll really put our design to the test by walking through the most critical part, the booking flow. To really stand out, we'll add a smart feature like dynamic pricing. And finally, we'll talk about how to make sure our system can scale up to a global business. Okay, first up, requirements. Functionally, what does it do? Well, users need to be able to search, reserve, and manage their bookings. We'll also need an admin portal for managing the car fleet, and of course, a super secure way to handle payments. But just as important are the non-functional requirements, how it performs. The system has to be highly available, it needs to be fast, and it needs to be secure. And this one is absolutely critical. It must have strong consistency. Why? Because you simply cannot have two different people booking the exact same car for the exact same time. For a rental business, that's a total disaster. With our requirements locked in, we can start sketching the blueprint. A really modern, scalable way to build this is with a microservices architecture. All that means is we're going to break our big, complex system down into a bunch of smaller, independent services that each do one thing and do it really well. So what would those services be? Well, our clients, the web browser and the mobile app, will talk to a single API gateway. You can think of this gateway like a traffic cop or a bouncer at the front door. It routes all incoming requests to the right backend service. We'll have a user service for handling logins, an inventory service that knows everything about our cars, a reservation service for all the booking logic, a dedicated payment service, and a notification service for sending out emails and alerts. Let's trace a simple request, just to see how this all fits together. A user searches for a car in San Francisco for next weekend. That request hits our API gateway. The gateway sees it's a search query and knows exactly where to send it, the inventory service. The inventory service then queries its database for all vehicles in that location that are available during those dates. The database returns a list of cars, and that list travels all the way back to the user screen. It's simple, it's clean, and every component has a very clear job. Now let's talk about the foundation of our entire system, the data. How are we going to actually store all this information about our users, our cars, and our bookings? This is where we need to design our database schema. We can pretty much identify four main things we need to track. We'll need a user table for their info, a vehicle table with all the details like make, model, and its current status. Is it available, rented, or maybe in for maintenance? The reservation table is really the heart of the system. It's what connects a user ID and a vehicle ID with specific start and end dates. And finally, a payment table to keep a clean record of every transaction tied to a booking. Okay, let's connect the dots. The relationships between these tables are what make the whole system work. A single user can have many reservations over time. That lets us build out a rental history for them. A vehicle, too, can have many reservations, which lets us track its entire life. The link between a reservation and a payment is a strict one-to-one. That's just good accounting. Getting these relationships right from the start is what lets us run complex but efficient queries later, like, show me all the cars this user has rented in the past year. So, the big question, where do we store all this? For the core parts of our system, the booking and payment logic, A relational SQL database is definitely the way to go. It gives us ACID guarantees. That's a super important concept here. It means that a whole transaction, like creating a reservation, processing a payment, and updating the car's availability, either succeeds completely or it fails completely. You can't have a situation where a payment goes through but the car doesn't get reserved. For other stuff, like maybe vehicle descriptions or photos, a more flexible NoSQL database could be a good fit. All right, we've got our blueprint and our data foundation. Now for the moment of truth. Let's walk through the most critical workflow in the entire system, step by step, the booking process. This is where all of our different components have to work together in perfect harmony. So a user finds the perfect car and hits reserve. That request zips over to our reservation service. The very first thing it does is create a reservation record with a pending status. This basically puts a temporary hold on that car for, say, 10 minutes. Next, the user is sent over to the payment service to handle the transaction. If the payment is successful, the payment service sends a thumbs up back to the reservation service, which then flips the status to confirmed. At that exact moment, it also tells the inventory service to mark that car as unavailable. And finally, the notification service kicks in and sends that satisfying confirmation email. So what's the most dangerous part of that whole flow? It's that moment when two users try to book that last available car at the exact same time. This is a classic race condition. That pending state we created is our first line of defense. But to really solve this, we need a locking mechanism. We could use what's called a pessimistic lock on the vehicle's record in the database, which would force the second user's request to wait. Or we could use an optimistic lock, where we just double-check that the car's status hasn't changed right before we confirm the booking. Both are great strategies to bring up in an interview. Okay, we've built a solid, functional system that works. But in an interview, you always want to show that you can think beyond the basic requirements. So let's add an advanced feature that delivers some serious business value: dynamic pricing. So what is dynamic pricing? It's just the idea that the price of a rental shouldn't be static. It should change automatically based on what's happening in the market right now. Think about how airline tickets or Uber rides work. The price shoots up when demand is high, and it drops when demand is low. We can apply that exact same logic to our car rentals. Now, what's really cool is the data we can feed into a system like this. We look at our current fleet availability, seasonality, maybe a big conference or concert is in town. We could even have a process that scrapes our competitors' prices. This logic would probably live in its own dedicated pricing service, maybe using a simple rules engine or even a small machine learning model that gets smarter over time.
And this quote from Kbisoft really sums it up perfectly. This isn't just about trying to squeeze out more profit. It's about optimizing your entire fleets, cutting down on manual work for your staff, and ultimately building a smarter, more responsive business.
Our system is looking pretty feature-rich, but can it actually handle success? Let's quickly talk about how we would scale this design to handle millions of users, and then we'll wrap it all up with the key takeaways for your interview. The beauty of our microservices architecture is that scaling becomes much more straightforward. If our inventory service is getting hammered with search requests, we can just spin up more servers for that specific service. That's horizontal scaling. For the database, we'd use a primary replica setup. The primary database handles all the writes, the bookings, while multiple read replicas can handle all the heavy search traffic. We'd also add a cache, something like Redis for popular searches, and use a message queue to handle tasks like sending notifications so our user never has to wait for those. And of course, we need fault tolerance. In our design, every single component, each service, the database, the cache, would have replicas. If one server goes down, traffic just gets automatically rerouted to a healthy one. The goal is to have absolutely no single point of failure in the system. So, to wrap this all up, here's your 3-step plan for nailing this question in an interview. 1. Always clarify requirements first. 2. Start with a high-level blueprint. Get the boxes and arrows on the whiteboard. And 3, probably the most important tip, always talk in trade-offs. Don't just say, I'll use a SQL database. Say, I chose SQL for the reservation data because I need strong transactional consistency, but I'd think about NoSQL for user profiles to get more flexibility. That shows a much deeper level of understanding. We've designed a really robust and scalable car rental system, but the design process is never really done. So I'll leave you with this question. What's next? Should we add a customer review and rating system? Maybe GPS tracking for the vehicles? Or what about an insurance management module? The possibilities are pretty much endless.